Now that I can do my one step, I can get a little fancier. I can start at any one of these outside places of my mole center, and I can now go between them, but I have to stay on the sidewalk, okay? Moles don't like to stray off their sidewalks, they like to stay on them. So if I'm going from my mass to Particle Park, I can't take this detour across. I have to stay on the path. So I have to first go from mass to moles, then moles to particles. Or from particles to Volume Village, I have to go from particles to moles first, that's one step, moles to Volume Village. So we call moles the key because they're the hub. We have to go through my mole center in order to go anywhere else. So when I do these, I always follow the same steps, so that way I don't make mistakes. So I first want to ask myself, what am I given? So what are you given? And that's always a number. And then what are you trying to find? So what do you want to find? Once I know what I'm giving or what I want to find, I want to know how will I get there. And that's using my mole town. And then I'll use my conversions from my mole town. Because remember, our mole is the key. So, convert 10 grams of sulfur dioxide to molecules. I start with what I'm given, 10.0 grams sulfur dioxide, and I'm converting to molecules. So molecules, SO2. I look back on my mole town sheet. I'm going from grams to particles. Can I get there in one step? No. I have to first go to moles and then to particles. So I draw that. I can't get there in one step, so I first go to moles, then I can go to molecules. So 2 steps to do so. To get between grams and moles, I use my molar mass. And to get between moles and molecules, I use Avogadro's number. Okay. My molar mass of sulfur dioxide, 1 sulfur, 2 oxygens, gives me a molar mass of 64.07 grams per 1 mole. Avogadro's number, 6.02 times 10 to the 23rd molecules per 1 mole. So I start with what I'm given to do my conversions, 10.0 grams sulfur dioxide. I had 2 conversions, so conversion 1 and conversion 2. My first conversion is grams to moles, so my grams drops down. And I'm going from grams to moles, so moles goes on top. And my second conversion is from moles to molecules, so moles is on the bottom, and then molecules is on top. And then I go back and fill in 64.07 grams per 1 mole, and every 1 mole, 6.02 times 10 to the 23rd molecules. Molecules. When I plug that in, multiply across the top, divide by the bottom, and I get 9.40 times 10 to the 22nd. That's the whole number, and that's molecules, sulfur dioxide. Alright, let's try one more. Here I'm going to go from the volume in liters, what I'm looking to find, if I'm given 200.1 grams of nitrogen dioxide. So I'm going from grams, have to convert to moles, from moles to volume. So 2 steps again. So I start with what I'm given, 200.1 grams nitrogen dioxide, 2 liters nitrogen dioxide. I can't do it in one step. I first have to go to moles, Then for moles, I can go to liters. So I have 2 steps. 1, 2. Grams to moles, we use our molar mass. I have 1 nitrogen, 2 oxygen, so 14.01. 2 times 16.00. I get a molar mass of 46.01 grams per mole. To convert between moles and liters, 22.4 liters is equal to 1 mole. Now I have my conversions. I can start with what I'm given. 200.1 grams nitrogen dioxide. I have 2 conversions, 1 and 2. I take my units, drop them down, grams NO2. I'm going from grams to moles, so moles, nitrogen dioxide's on top. My second conversion is going from moles to liters, so I take my units of moles, drop them down again. I'm going from moles to liters, so liters goes on top. And now I go back and plug in my conversion factors. So grams to moles, my molar mass, 46.01 grams. That matches my grams per 1 mole. And then 22.4 liters per 1 mole. 200 times 1 times 22.4 divided by 46.01 gives me 97.42 liters nitrogen dioxide.